Hello, good morning, everybody.
Good morning to the participants. Welcome to the today section, today section. Welcome to all the participants. Today, Mr. Deepak Sir is with us to enlighten us on the concepts of issues and challenges related to EVs. Welcome, sir. Welcome, Deepak Sir.
Hi. Yeah, thank you.
Welcome, Deepak Sir. Please on the video, sir.
Yeah, I can be on audio for some time and then I can click on the video.
Sure. Okay. Thank you, sir. Thank you, sir.
I can actually go ahead and
Mm.
continue the session. Good morning, everybody. Good morning or good evening. I think everybody are from various parts of the world. Am I audible?
Yes, sir. Audible, sir.
Yeah, okay. So actually, let me introduce myself. I'm Deepak. I'm going to share my thoughts and my knowledge regarding the EVs and electrification. Basically, I'm a mechanical engineer, born and brought up in India, and my work experience consists of 18 years as a design development and product development engineering. Worked as a project manager in various projects, and finally, getting busy in electrifications. So, though my slot is more than 1 hour, but looks like it doesn't take much time for me. Um, it's a crisp kind of thing, just a knowledge sharing kind of thing. So what I have and what I expect from you. So I would not ask you any questions. Just sit back, relax, and just listen. You don't even note down any points also, because it's a kind of smooth going and kind of like a storytelling kind of thing. I'll make it more interesting, and most of the people might be knowing what is EV means or maybe hybrid means, and most of the people 100% of the people maybe but it's a brush up for you guys if you know 100%, and I'm targeting who don't know. Actually, I know 10%, 15%, so they can understand. And I would start with a very slow pace, and try to make you to understand, though the subject is a very vast subject, and I would not take and make you people bored. Okay, so let's make it very simple, and also I'll try to connect the dots. Maybe I'll jump up from a subject to subject, or maybe from topic to topic, but definitely I'll try to make you to understand, and I'll try to connect the dots. And ask me if you have any questions at the end of my turn, and you can take your turn, guys, and then let me see if I can answer your questions. So I don't know, everybody are from automobile background, mechanical background, and electric background, and electronics, because there is a kind of like four branches actually, in engineering are getting connected with this topic. And the electronics, electrical, under one branch, and mechanical, automobile. So we'll say if everybody are automobile enthusiasts. I don't know how many people watch racing, Formula One, E-Formula, NASCAR, Superbikes. Anybody into racing, go-karting? A little bit more understandable if you guys know about automobiles. Anything is okay. Anything is okay. So if you drive bikes, if you drive cars, anything is okay. So our subject will be like slowly getting into passenger cars, and maybe EV passenger cars, and slowly getting into the buses, or maybe we'll end up with the trucks. And so no confusion. I can go back and forth, and then I'll try to explain. I'll try to explain as much as I can. So my explanation will be very crisp and clear, very short, um, and the whole story begins. The whole story begins with a person like you everybody know like Elon Musk. So it was in 2015. Let me start with that. But he might have introduced a little bit of EV cars like in 2009. Let us talk about a bit before what happens. Like we'll put that a guy who actually introduced a electric car, and we can say like before that and after that, and see like what is happening, and then we can connect the dots at the end. So I would say like let me start with that like somewhere in 2000s, like when a Japanese manufacturer working on a hybrid models, and 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 see like in 2000s, late early 2000s, they introduced a car with a hybrid model. And the hybrid model is a mixture of, you guys might have known, or what is a hybrid car. Hybrid car is a mixture of internal combustion and electric motor. So um, this is how you'll get a fuel efficient car. And uh, generally generally if a gallon gives you 20 miles, and with a hybrid you'll get 30 or 35 or 30, you can say. And then that with a auto transmission. So you have three transmissions: manual transmission, automatic transmission, and CVT, continuous variable transmission. So generally what happens, if you connect the hybrid thing with a uh, automatic, and if you get a 30 miles per gallon, and then they started doing it with a CVT, connected to the CVT, and see like if that one is like working tremendously and giving us like good results. So they started working on that, and they achieved that for 35. So it was in early 2000, 2006 and 2007 they introduced that. Maybe you might have known about like Toyota Camry or maybe Honda Accord, but Toyota Camry like was the first car like what they introduced. So and then the CVT is a kind of thing like you'll never feel the sudden shift in the gears. So it's a soft kind of thing, and a slow one, and which gives a very good fuel efficient. So that's how a hybrid started in 2007. Um, so Toyota wants to achieve a fuel efficient passenger car. So they introduced on the American roads, but at the first, like much of the people don't actually like the way, like with most of the people was like muscle cars, fast cars, in early 2000. But later they were like there were so many companies coming forward to make it as hybrid. So even the Ford manufactured electric cars, I mean hybrid cars. And from 2007 till date, we have Ford, Nissan, Honda, Chrysler, you name it, like most of the cars have a hybrid session. We have, and the next one is like hybrid. One is hybrid, and the second one is plug-in hybrid. And there is a third one which is actually like in a dilemma, like whether we need to go ahead or we need to stop. And that was the fuel cell. Fuel cell is under research and development still. They started a 7 years or 8 years back, but still in a dilemma. Now comes into like EV, electrification, electric vehicles. So electric vehicles, since like 2009, a Roadstar was released, and there were more companies. The guy Elon Musk, like came into the picture in 2015, and he released a car, that's S series. You guys might have knowing. So that was the spark actually, like people actually wanted to jump into EVs rather going for a fuel cell. Fuel cell does have pros and cons. More than the pros, like there is horns everywhere. So so they have like bigger tanks coming at either side of the car or maybe the back side of the car, and the discharge will be the water. So they have their own problems to still in research and development. But EV is a kind of thing like a fully electric vehicle. So the torque is more, and you guys might have like googled it everywhere, like what actually that does it does the car do. And in 2015 to 2017 there was like huge thing in the market, like every car manufacturers wanted to get into electric cars. So let me I can share let me share. Give me a minute.
Sir, Deepak sir, is there any difficulty in screen sharing, sir?
No, no, give me a minute. I'm just trying to pull it. Uh, I don't have any problem, but the problem is with my system only. So
No issue, sir. We will wait, sir. No issue.
apologies, guys, because I don't have the certain software, but I can just pull it and show you. Share. Can I send it to you so that you can share slide by slide? I can explain
Yes, sir.
because
Sir.
yeah, I
Sir.
have problem here.
Yes, sir.
Yes. It's not much. It's 6 to 7 slides. That's it.
No issue, sir. Please share it, sir. Yes, please.
Okay. Okay, I'm sending it to your email ID, Sridhar. Guys, please bear with me. It should be in your inbox.
Okay, sir. I am checking, sir.
Yeah. Meanwhile, we'll. Oh, okay. Okay. So this is actually you can actually maximize that and yes, thank you. So I just put, I didn't put lot many slides. This is for our understanding what we are doing right now with the hybrid, plug-in hybrid and electric. So yeah, the first one is hybrid vehicle. So this is how a hybrid vehicle will be like, in the passenger cars. We still have fuel. We still have internal combustion because hybrid vehicle is a mixture of internal combustion and a electric motor. So that's an external electric motor. So we have here we have here a fuel tank, we have traction batteries, we have electric traction motor, electric generator, we have transmission. We have everything a conventional passenger vehicle have. On top of that, we have a electric motor here. So that's how even even the engine is I4. So we'll get the power like a V6, and it is on par with a V6 car, and also it's a fuel efficient, and maybe the starting traction is not that much like a conventional passenger vehicle, but you'll definitely have it will get um, 6 seconds 60 speed or something like that. You can expect that in 8 seconds, but anyway, it's a fuel efficient vehicle. So that's how a hybrid electric vehicle will be. So and you can go to the next slide. The next slide is plug-in hybrid vehicle. So plug-in hybrid vehicle, you have the same thing like the internal combustion, and you have a um, the battery, the motor, and everything. And on behalf of that, everything is fine with the hybrid vehicle. But this plug-in is something like you have an electric traction motor with the charging point. So where you'll be charging the batteries separately. So that means the hybrid vehicle actually charge your battery, but you are externally charging your external batteries with the charging port. So that means it's kind of like a semi kind of going into the electric vehicles. So you have a hybrid plug-in hybrid, and the next one would be like electric vehicle. But here you have everything looks like the same like a hybrid, but you have a charging port which is actually charging your external batteries. So batteries, I mean, you have two batteries here in hybrid. You have a 12 volts, which you have, under your hood, which actually like, a conventional passenger car. You have the same thing with the 12 volts, and there will be like an extra bulky battery, which is actually giving power to your electric motor. So which it goes to the electric generator, and it gives boost to the electric motor, and then to the transmission. Next slide. Okay, this one is a hydrogen, fuel cell vehicles. The fuel cell vehicles, the fuel is hydrogen. You'll have a bulky tanks at the back. You can put it anywhere. Like, there some of the cars like they can putting, yeah, they are keeping the hydrogen tanks under the passenger seats. And this one, which you are showing, which you are seeing here, those green tanks are actually way back, on the, on the second row of the car, and also under the seats, and maybe it is extended to the trunk also. So under the hood, you have transmission, you have battery, and you have electric motor and everything, but you have a fuel cell stack, and you have a discharge bottle also, which the water will be get, the output will be a water. When you have a gas passenger vehicle, the output will be the exhaust, you'll get carbon dioxide, and then now this one is going to be like, you'll get water. And this is still under research and development, and not into production right now. And so you can go to the next slide. So this is electric vehicle. This is how it will be, in a electric car. So did you see that, um, we have separate three types of, three or four type of chassis are there right now. We have a ladder frame chassis, we have a backbone chassis, we have tubular chassis, which is used for the racing cars or whatever, and we have monocoque chassis, that what we are actually using in the current production cars. So if you see here, on the frame, the batteries are getting stacked up here now. It's yellow ones are the batteries. So they'll put it on frame and on the chassis, and you have the electric traction motor, you have a transmission, and you have onboard chargers, and you have full of electronic control modules. ECUs are there. Everywhere you will get an ECU. And there are traction battery packs are there on the yellow side. Those are the battery packs. So it will be stacked up. I mean, it will be stacked up, like, into two layers, and then, from front driver seat to, you can see, like, till the trunk, you'll get all the batteries. So this is how a electric vehicle packaging architecture would be. And this is a passenger car. And you can relate this with the Tesla or some other cars, Nikola. But this is how they made it. You can go to the next slide, sir. Um, yeah, this is monocoque chassis, and if you can see on the um, right side frame, there is a if you can give me how I can take the axis. Okay. The top picture is, on the top, you're seeing a cage, and then you'll go to the second line on the right side picture, which you can see, like, there are two wheels facing us, and there is a motor on the middle. So the center one is the motor. So what they did actually, like, for the drive wheels, they put it on the back side, and this one is a model from Tesla. What they do actually, single motor car and dual motor. Dual motor is something like, four-wheel drive, and the single motor is a rear-wheel drive. They tried to put it on, back and forth, and then they saw, like, the push-pull situation. You guys know about the push and pull, the front wheel drive and the rear wheel drive. So they put it in the push situation, and then they tried it, and it worked well. So for the slippery condition and traction conditions, they want to make it as a dual motors. Dual motor is something like one motor on the front side and one motor on the rear side on the two axles, and here you don't have a prop shaft. Generally, for the rear wheel drive, you'll have a prop shaft which is connecting from the front transmission to the rear axle. But here they put it on individual motors, and then they see, like, what it is actually giving a correct output or not, and they achieved they were actually success in that. So this is a rear wheel drive, and there are one motor on the back side. And go to the next slide. So this is from top view. That's what I was explaining. So how they made it. The red one is the motor. Guys, I just want to bring up a little bit um, more about, what is happening in the electric wheels. There is a name called region. Region is something like, you know uh, ongoing battery charging for EVs. So what happens actually, if you guys know about car or a bike, I'm taking you to the actual situation. So you're driving a bike, you're driving an automobile, and you gave an accelerator. And what happens to the automobile? It will go, and then when you reduce, I mean, when you release the acceleration, the bike goes to, certain limits. Like if you are on a 60-mile speed, it goes to 1 mile or 2 miles, and then it will gradually slow down. And even in the cars also, it gradually slows down, and then, it stops in certain place. But what happens here in an electrical vehicle, uh, you push the accelerator, and then it goes on a certain speed, 60 miles, and then there is a motor which is actually moving, like, on the front direction, right? I mean, like, in the forward direction. So the wheels were, like, moving in a forward direction, the car is moving, and then when you release the acceleration, there is a technology called regen. Regen is something that motor will go backwards. What happens? The motor goes backwards. Um, the motor goes backwards, and then the wheels will be moving in the front direction, and it doesn't allow you to move for a longer time, because on the other side, when the motor is actually revolving to the, you know, to the other side, it is actually charging the batteries. So you can also tell that, in other ways, like it's a reverse acceleration or a brake kind of thing. And usually you actually tend to see that in remote cars actually. Did you ever, like, any guys, like, play with remote control cars, RC cars, racing cars? So what happens in the battery cars? You charge it, and then it's a battery operated, and you have only two things, like, front and, there is a lever, the front and reverse, and there is another lever, right side and left side, which you will be maneuvering, like, to the right and left. So what happens in the same situation in the toys also? You actually click on the front side, and then it goes, and when you release it, and it will stop for some time, like, like in a few seconds. But in the same that's the same situation happens here. It's a region. We are using a word called region. So region is something like, the motor goes front side, like when you push the accelerator, and when you release it, it will allow you to go for a couple seconds, and then, it slows down, and you'll be like, what is happening to the car, like, why it is stopping in the middle. As long as you press, it goes. As long as you release, it will stop. So you'll be getting astonished, like, when you are driving a conventional car, and when you drive a electric vehicle. So when you drive an electric vehicle, the car is stopping just because the region is getting, and then, the reverse motor, and then it is charging the batteries. Okay, so that's actually the technology what now the industry is using. So it is actually carry forwarding to every other companies. And then can you go to the next slide, sir? Okay, this one is before going into this slide. I just want to explain you what is this, and why we are jumping from passenger vehicles to this slide. This slide is actually a topology of a truck, the semi truck. Um, why we are talking about the semi truck means, like, the EVs are not restricted to passenger vehicles. EVs now are getting introduced to off-road highway trucks, semi trucks, and also construction equipment. There are certain companies, like, mining trucks. Did you ever heard about mining trucks? Mining trucks are, like, off-road vehicles, and I can say, like, there are plenty of companies actually uh, getting into the EVs. Electrification is a word that what the industry is using in off-road and construction vehicles. I worked with one of the big giant Caterpillar, and I I've been like, was there for a couple years, and then when the project, we just started the project, and there was like few guys who actually started the project, that is electrification. Did you ever heard about like backhoe wheel loaders, track type tractors? So those are like heavy earth moving machines. And also 797, if you can Google it, Caterpillar 797B, so you can definitely get it. So that's a huge mining truck. That's a very huge mining truck. So, you know, the tire of the truck will be like, 7 feet or 8 feet high. Even if you can jump, you cannot touch the tire end. So that's how it's big. So even those trucks are also getting electrified right now. So that's the same technology they are using. So that is off-road vehicles, but this slide, what we are seeing is on-highway trucks. On-highway trucks is for transportation. So I would definitely explain you what is happening here. There are some numbers on the right side. Uh, you know, the orange numbers. Don't worry about that. Starting from the left, I would say like there is radiator. The next one is engine. The next one either side of we have the batteries, and the middle either side of the batteries. Middle one is a transmission light, and then and there is a sleeper box that is invisible on coming on the top of the chassis. That's the back of the cab, and you can see there is a prop shaft going from transmission to the end of the rear axles. So this is how a topology, like what the trucking industry, like right now. And now on the left side you can see that's a kind of like wired model, which is actually made it in a 3D modeling software. So this is actually right now the trucking industry. So what happens again, you know, the guy actually introduced 2017 a semi truck, and then the whole industry was like, oh man, this one is not going anywhere. The conventional, the engines what we have is not going anywhere. So we need to get into something like electrification for these trucks, and then make it possible that electric truck is also going for 400 miles on a full charge. So we have front Freightliners, Packard, Western, International, Mack, Volvo. So every trucking industry, like yes, we have to get into the electrification. So that's how these guys was like before Tesla introduced the semi trucks, these guys went into production also. So they started working, all the trucking companies started working like since 2017. So they made it as a project. 2018, the design development has been done. The R&D has been done in 2020 when it was, in COVID. And then 2021, like they went into production. So, but 2017 in an exhibition like Elon Musk showed there's a semi truck coming up. So, but these guys went into already into production. The semi truck, the Tesla, it will be going into production in 2023. That's a different story. But I'm just comparing with what we have in the industry and what we don't have. And can you go to the other slide, sir? That's the one we have. There should be one more. Yeah. So we have a different model here for the trucks. Um, the yellow one, which is actually the frame, chassis frame. The chassis frame consists of the right frame and the left frame. So what happens, like there are some companies who are actually stacking up the batteries, or maybe like putting up the batteries on the inside the chassis frame, and then it goes like from front to back. And then those wheels coming on the front and back of the wheels, they are just replacing the axles with the e-axles. What is an e-axle? E-axle is something like you put a motor in the axle, and there will not be any prop shaft from the transmission. The transmission will be gone, and then you'll have a transmission and a motor coming inbuilt in the axle. So that's how in the rear side you have two axles, two E axles will come, and the front will be like, it's just, a normal axle will come. So there will be a battery stack up on the either sides. Sir, can you go to the previous slide and maximize? Okay. So yeah, maximize. Yeah. So on the right side of the picture, if you can see, there are fuel tanks coming up, right? Um, I just minimized, like, I just made it so small. Yeah. So there are fuel tanks coming on the either side of the chassis. So nowadays, like, in some of the companies, Freightliners and Packard, they are just making a huge bulk of batteries, replacing those fuel tanks. The fuel tanks will be like on 600 gallons on the either side, and now they are keeping, like, huge battery packs, like 4 packs, 4 packs, 8 packs, and which gives a 410 miles on a full charge. So that's how right now going with the passenger cars and trucks, and also with the construction vehicles. um I mean, I tried my level best to connect the dots, and this is what right now going in the industry. And being the program manager for the design and development for electric vehicles, this is what I can show you, and this is what I can share the knowledge. Let me know if you have any questions, and let me know, shoot me any questions. I'll try my level best to answer, or maybe if I don't get the answer, because I'll definitely get back to you guys and send you an email on this.
Thank you very much, Deepak sir, for enlightening our participants related to development of EVs and different design aspects. Some of the participants, they put the queries, and related to battery management, they're asking now lithium ion they're using as a material. It is costly. Is there any alternatives? You can suggest any research is going on related to the alternatives.
Every company has their own manufacturing units right now, and every company has their own, subsidiary companies are there. So lithium battery is okay. It's an expensive one. I do agree with that, but there is no other go with other alternatives right now. The research is going on to make it a bit cheaper for those for the cars, but I don't think so. Like, in near we'll get it. Um, but it is, like, more efficient than a hybrid battery. So right now the production is going on with the lithium batteries. Huge production is going on everywhere. So they're trying to make it to cut the cost. Let's see, I don't have any information on that, but right now the industry is going on with the lithium only.
Okay, thank you, sir. Related to development of more torque in hill areas, EVs are facing difficulties. What more work is going on to improve in that aspect?
um the torque wise, if I can take an example of what happens here in United States. When a car is manufactured, or when a truck is manufactured, like, it will be going to various parts, hilly areas and high altitudes. Usually all the trucking companies concentrates on Colorado. Colorado is a place where all the trucking companies will, they have their branches there. They'll test in the Colorado itself first, because they have the high altitudes, and they have the hilly areas. Yeah, yeah, it's a challenge right now. The traction is a challenge right now. um, but people are not finding any problem because of the weight they are carrying on the truck, and also We don't think so. Please don't think that, electric vehicle is very light, because either side of, like, what they are stacking up the batteries, and also back of the cab, there are huge batteries are coming. It is on par with a conventional truck. The weight will be like on par with a conventional truck. You have a, let's wait with an engine, transmission and everything, and let's wait with the full battery pack and everything, and it's on par. So weight wise it is on par. So they're not finding any problem in that. And more or less, when they test engines in the Colorado, most of the time, like in a high altitude, they could see, like, there is a breaks, there is a cracks in engines. They're used to get the cracks in engines because of the high altitudes and the high power, like, they are using. But in the electric vehicles, they don't see anything like that. Though this is a startup like kind of thing, like, when they go with the production, high and full speed of production, they could be like, back and forth designs will be there, and for rectifying these things. But for electric vehicle, they don't see anything right now when they are driving on high altitudes or in a hilly areas. The traction is like, completely on, under control.
Sir, one more query, sir. In India, five top EV cars, Audi e-tron, they're quoting that in 35 minutes they can able to charge the battery, and car can run up to 500 kilometers. Then BMW, they are keeping two motors in the vehicle, uh, four-wheel drive facility, 76.6 kWh, and it is taking 7 hours to charge the battery. Then BMW i4, they are quoting only 31 minutes, and Jaguar, they are quoting that it will take nearly 1 hour, 10 minutes to charge the battery, like that. Then what will make the difference for charging the battery time?
Hey, that's a very interesting question. Even I just want to cover this in my, when it was my turn, and I couldn't cover it. But that's a very interesting question. I can answer this in a very logical way. If you have a car with you and you are the manufacturer, and I'll take my turn. I'm the car manufacturer. I'll release a car with two different things, like, hey, this is my car, and it actually charges in 5 hours, and this is another version, and it charges in 45 minutes. And I would say, like, this, for this charge, I will go with $10, and for this 45 minutes charge or 1 hour, I'll go with $50. So that means, like, I'll put a price on, like, how fast you charge, and I'll put a price how slow you charge. So I don't think so, like, people gonna wait for 6 hours or 7 hours. Definitely, like, you want to put some more money, and then you make it for charge like 45 minutes. It's a very easy thing, like, it's a very easy thing and a catchy thing right now, what the industry is doing. um, and I can tell you one example. If your car is a electric car and you guys are on full charge, you want to go you want to go to a distance of 400 kilometers. The car says it is 400 kilometers, and then you'll have a full charge and you'll start your journey. Then you'll put your AC, and you'll use your audio. It's a premium audio, full bass, full treble, and everything. And then you guys charge your phones in the car. You'll put AC, and then after 200 miles, the power will be done. And then you'll go to a gas station, I mean charging station, and then you'll say, like, okay, do you want to stay for 7 hours, or do you want to stay for 45 minutes? So you'll put $50, and you'll go for a quick charge, or you'll stay for 7 hours and you go for a slow charge. So that is up to you, like, what the car manufacturer are doing. It's a tricky one, like, what you want to choose. And there is nothing like Audi or a BMW or some other company. every car company is using the same trick and doing the same thing. And also, I just want to connect the dots. When you are going for 500, 400 miles and you are stopped at 200 miles, it just because the car manufacturer says under conditions. You don't use your AC, you don't use your music system, and don't charge your phones inside. And not all the four members. If you are going alone on your personal weight, like 80 kgs in the car, you can go for 400 kilometers. But if you are like fully loaded, five guys with AC, with with music system, it never goes for 400 miles. I bet you guys. So that's a catch here. So all the people are, are after the EVs, but EVs are something like, promising when you are like, alone going in the car. But if I want to answer for the charge, I would say like, I would release two cars. One is for 7 hours charge and one is for 45 minutes charge. It's the same thing happening with the Tata Motors also. I heard like, there is one car like which goes for 7 hours charge and which is like doing for a quick charge for 45 minutes, if I'm correct. I hope I
Yes,
answered.
sir. Yes, sir. We understood, sir. Thank you, sir. And from Sir Kulkarni, sir, is asking one query. What innovative methods, technologies are under consideration in US to reduce size and rating of battery? Related to USA, what methods and technologies are under consideration to reduce size and rating of battery?
Looks like I don't know. Looks like a generic question, not to the point. As far as I know, like, to reduce the size of the battery, I might get back to the question again.
I'm speaking, sir. What innovative methods and technologies are under consideration
No,
in
no,
USA?
I can get back to this
Uh,
question
uh,
again. I can go
okay.
to the next question. I'll get back to
Okay.
this question because it
Okay, sir.
looks like
Okay.
more generic. How
Next
much
query.
effect would be there on battery life in case of regular charging? Um, some companies are, they say like warranty kind of thing, like 150,000 miles or maybe 10 years battery life. So this is how they are promising with minimum of 5 years to 10 years. We don't know like how many charges are there, but the warranty will be like there, 5 years or 150,000 miles. An average car, per an year is 15,000 miles, and if it goes like 150, it would be like 10 years. So depends like how soon you'll get it. Maybe 7 years or 6 years. If you get a 150,000 miles, the warranty will be covered. What battery size capacity used in electric trucks and long years the battery standards? The trucking company, they are only promising a minimum of 5 years. They're not promising like more than 200,000. Passenger cars are really separate from different from the semi trucks. The semi trucks have like 200,000 miles. Uh, so maybe a 5 years. Nexon EV. Yeah, Nexon EV, Tata Nexon. Yeah. When we design dual mode bike, can we also use this system with single axles in a car? When we design dual mode bike. Are you talking about comparing about the bike and a car? So it's a electric plus petrol. It's a hybrid one you're talking about. Can we also use this system with single axles in a car? Hmm. You're talking about hybrid car, right? You're talking about hybrid and hybrid plug-in hybrids. How to retrofit an old bike into EV? Hey, that's a really very fantastic question. Guys, if you are really interested into that, um, you know, Google something, and in YouTube you have plenty of things. Our friends like made two go-karting bikes. Just take off the engine, and the drive chain will be still there. And we tried with for our kids. My kids are like 8 years and 12 years. So for them, we did a go-karting kind of thing, two go-karting things. Did you ever know about power tools? Power tools, electric power tools. So the electric power tools coming with a battery, so 20 volts and 40 volts. So so we took off the battery and then we put it there and we put a electric motor there. Now it is go-karting. We started that, working on that, putting some weldings and putting the motor on there. It has taken for us like 2 months or 2.5 months. So we're still doing that to make it a better one. But this is our my friend's hobby. We usually go there. um, what is the efficiency of recycled battery? I can't answer that. Which type of, because always a recycled battery is a recycled battery. And I can take an example of a hybrid car. Like, you have a new battery which has 150,000 miles, and you always have a second sales market. So these batteries will go to the recycled batteries, and then they'll recycle it, they'll repair it, and then it comes back. So the efficiency will be the same, but the life will not be the same. So you'll be like warning out on 1 year. So you'll not have any warranty on that. Which type of aerodynamic study of EVs still have the same aerodynamic studies like a conventional cars. It doesn't change. Aerodynamic will be the same. Serval battery. Yeah. Battery cars and EVs, it definitely affects the environment, but a lesser than the gas engines, but more than the hydrogen fuel cell. That's what the fuel cell is going on right now. Maybe not right now. It's still in R&D. Maybe after 5 years or 6 years, definitely those hydrogen fuel cell cars will definitely come into the picture, which affects the environment very less than the electric cars. Can we convert old cars to existing EVs? Yeah, you can convert it, but rather going for a conversion on your own, you buy a EV car. That's more cheaper. How to waste batteries of electric trucks managed? Um, it's $1 million question right now going on. Yeah, it's affecting the environment. You guys might have heard about the junkyards here in automobiles in US. So now those will be replaced with the batteries, I guess. I hope I answered your questions. If you still have any questions, just let me know. And my time it is 12:30 midnight. So I think I fully use my time.
Yes, sir. Yes, sir. Thank you very much, Deepak sir. Even though time zone is different, at midnight time also, we
That's fine.
interacted with our participants. We have troubled a lot. Still, with consideration, you have addressed our participants and you have given valuable information.
You
And,
can still be in
mm,
touch with the host, and if you have any questions, or if you need any links or journals or anything like related to the EV or comparison between the hybrid, plug-in hybrids and whatever, I can send some links to the host and he can be in touch with me. I'll see you again.
thank you very much, Deepak sir.
Thank you. Thank you, everybody. Bye bye.
Hope you'll have good interactions in future also.
Yeah. Yeah. Bye bye.
Thank you, sir. Thank you, sir. Good night, sir.
Good night. Bye bye.
Participants, for valedictory, we have some more time, nearly 60 minutes for valedictory. Meanwhile, Subramanian sir will enlighten us related to the features of EVs. Sir will join with us in 1 minute. Please stay online. In 1 minute, he will start his speech. Please be online. Participants, in the next minute, the session will start by Professor Subramanian, sir. Please be online. స్క్రీన్ షేరింగ్ ఇస్తాను. మీరు హలో రండి మామూలుగా మాట్లాడండి.
హలో హలో
బయట
హలో
ఉన్నాడు చెప్తాను.
హలో హలో ఆర్ యూ ఏబుల్ టు హియర్ మీ? హలో, గుడ్ మార్నింగ్ టు ఆల్ ఆఫ్ యూ. ఆర్ యూ ఏబుల్ టు హియర్ మీ?
వాళ్ళు మీరు వాళ్ళకి వస్తుంది, మీరు స్టార్ట్ చేసేయండి.
I will be speaking. Till date, you were being listening to various technical aspects of the challenges on electric vehicles. But I will not be speaking on that, but I will just tell you the general what is the problems and what are the various uh, reasons for we going to for the electrical vehicles. See, we now know the first and foremost, it's a very usually, and it is, everybody knows the biggest problem today is the oil price fluctuation. If you see my slide, the oil price fluctuations, it is continuously increasing, and there is nothing like a. I mean, if you see from the projected, this is our planned thing, but this is the actual price growth, and it is see over the period it is constantly increasing. It is there was a future phenomenon, but again it started rising. So this increase in oil prices is with the changing legislations between the OPEC countries and the BRICS. OPECs, they are having their own legislations, and BRICS also are having their own import. They are with a lot of restrictions on the BRICS country. The This rising prices on the oil prices, if you see, it will definitely affect the economy of the respective importing countries. The second biggest why these how these are this will affect the or it will have its impact on the vehicle. See, if you see the energy usage worldwide, industry breakup and light duty vehicles depiction, you see there is all other thing in the major sources. The India is having and all other countries you see the different countries thing, the energy requirement uses is tremendously increasing than compared to the prices of the thing. So if it goes like this, the annual requirement, it is say approximately about 600 billions is the maximum. With the 600 billion vehicles, if the things the used dollars gets coming, then the expected requirement of oil for these vehicles will be tremendously and enormously high. The biggest, another big challenge today is, of course, as we all know, is the global temperature anomalies. See, if you see the global temperature before 1940, it was always below zero, and now it is constantly and it is touching the peak. It is almost touching, and by 2000, it is almost touched the safety limits of 0.6 per degree. So if this is the rate of announcing, it is going to be a big threat in the coming decades on the temperature effect, and the global warming will be a major issue with the present trend of electrical vehicles. Now, let me go. I'm just sharing you the road transport emissions. షేర్ అవడం కదా. పెద్దది అవుతుంది. So if you go for the road transport emissions, if you see the what I call carbon dioxide emission, you see different percentage. The biggest percentage is the commercial vehicles is having the maximum carbon dioxide emission. Then commit to the whatever is the fuel type I'm using. This is another big challenge, the carbon dioxide emissions, which is growing compared to it proportionately. If it is buses and cars, it is all the commercial vehicles are causing a big issue for the carbon dioxide emissions, which is a challenge today for our, I mean, any over the global, entire the globe. If this is the trend, if this is the trend, what is the expected global emissions over the entire next year? You will find the different emissions which will be coming up. The worst will be with these vehicles, which mostly causing it. You see the trend, it is increasing, and the various passenger cars, two wheelers. This is two wheelers. This is all the differences how the carbon dioxide emission trend is increasing, and for the next this data has been collected for a limited period. If this is the trend showing, it will be gone increasing beyond for the next few decades, with as the passenger cars, the population of the passenger cars or the three wheelers or two wheelers, they'll be increasing. You know, we all the present scenario of the growth population, the people are not going for public transport, and non-motor vehicles are being very less used. People are using for mostly three wheelers and two wheelers and all these things. So this is the trend. There will be a, I mean, the emissions of carbon dioxide will be definitely meeting the means will be crossing the specified norms, affecting the greenhouse norms of the entire world. The socio-economic growth. If I say why I'm saying it, the socio-economic growth is affected. If I say, if you see different country-wise, if you see the usage of cars per thousand population in the thing, it is going on increasing. Earlier it was only restricted to high income groups. Now even middle and low income groups are also preferring to go for these light vehicles and two wheelers and motor, these light vehicle cars. This will be causing a case of concern for all the things when I go for the present system of vehicles and IC engines. This is the trend which is showing. If I'm just showing you the how the shift is taking place. Earlier, people used to travel with buses. Now with time, with buses and public transport, the requirement is, I mean, it is almost flattening. There is no much increase. With cars, jeeps, this was the trend, it is marginally. Now you see two wheelers, it is a steep rise. It is going on steep rise and it is going to increase. And if I say for the public transport shares, over the period time, with the population rise, even the population rise has grown more than 8. The public transport share, this is all the data connected between up to 2007. The public transport share is diminishing proportional to the whatever is the population, city population rise. When compared to city population rise, the public transport share is also changed. And if you see the changing shares of walk trips, even people are not preferring to earlier, when I go for it, when it was less than the, people were preferring to have walk trips. Now it is gradually the walk trips are also diminishing. You see, when it is going either thing, the walk strips are diminishing. The mostly uses of vehicles has gone for more. This is specifically all the two wheelers and all these things have gone up. So why I'm saying the shift between the earlier non-motor vehicles and the present day usage of all these motorized vehicles. With population growth, you see there is a continuous, with as the population increasing, it is not that the cars and two-wheelers have become the necessity. There is growing in the continuously increasing the things. You see, most of the things. This is the two-wheeler, this is the personal car. Two-wheelers and personal cars are becoming on the rise for the increase in population over the years. So, what is the solution? The solution, evidently, as we all know, we want to go for low carbon transport. So, electrical vehicle is definitely an answer. So, what does the electrical vehicles? Electrical vehicles and IC engine is that the electricity is they consume can be derived from different sources or a combination of RNG sources. This is the electricity that is being consumed. This becomes the source for as an alternative for sustainable personal transportation for all the to when we are coming to low carbon transport. Another is biofuels. వినపడడం లేదు ఎవరికి నాకు రెస్పాన్స్ బయోఫ్యూల్స్ ఇది పెద్దది పెద్ద biofuels, they are basically derived that are produced directly or indirectly from organic materials. This is the biofuel, but the biggest problems they have been around the the large scale production of biofuel transportation would require large land areas. As a result, its potential to replace fossil fuels is limited. So this is one of the biggest hindrance for the biofuels. Then second is now CNG. Of course, CNG compressed natural gas or the liquefied natural gas is definitely an alternative for the conventional fuels. It is cheaper and it is cleaner. One of the more promising alternative fuels. The biggest favorable is the price advantage of CNG over conventional fuel. There is a relatively price advantage of CNG over conventional fuels. This is one of the alternative source besides electrical ones for the for low carbon emissions. But already we know in this drive toward the CNG, Maruti Suzuki, Tata Motors, Chevrolet, Toyota Hyundai, all have already introduced at the factory fitted CNG vehicles, which are most popular in our India market. Now the next hydrogen fuel vehicles, the hydrogen fuel vehicles are one of the alternatives. They internally convert the chemical energy from hydrogen to mechanical energy for propulsion, either through burning hydrogen or an internal combustion engine or through reactions between hydrogen and oxygen in fuel cells that run electric motors. Hydrogen vehicles are divided by two different chronological approaches, namely hydrogen ICE and hydrogen fuel cells. Hydrogen ICE, they run on petrol and diesel and can be modified, and they can be modified to use hydrogen as a fuel in their internal engine. Whereas hydrogen fuel cells, cars are essential electrical vehicles that use hydrogen fuel cells instead of battery packs for power. Here, this is another scope. Besides electrical vehicles, hydrogen fuel vehicles is one of the alternative uh, for low carbon emissions in the present context. See, hydrogen vehicles, there is a lot of savings if I go for in the fuel economy and emission due to relying on both engines and electric motors for their power needs. Both it is relying both the things. The tank on wheel efficiency of electric motors is also significantly higher than IC engine. Internal combustion is than it is. The tank to wheel efficiency is definitely will be higher with this thing. So here I'm just giving various fuel combinations which can be used for hybridization. This is a different things. One is biofuels with the thing and is a dual form with CNG and other thing and liquid gas and gaseous thing can also be used as an alternative for using in hybrid vehicles besides electrical powers. Various combinations can be used. These combinations can be classified as per the things, and this is one of the scope for using and developing hybrid or dual fuel vehicles. Now, here there is another thing which advanced internal combustion engines, where people are thinking to develop IC engines with almost with reduced energy loss and improvement by and reduced tailpipe emission by reducing certain environmental standards, specifically the emission standards. Specifically, these emission standards are now being specified by various government regulation for different types of vehicles, and this is also being one of the all the automobile manufacturers, they have been asked to ensure these regulations are followed with the when producing their automotives with using ISO means as internal combustion engine, while keeping all these range, energy losses, tailpipe emission, mileage, all these conditions restraining it, that ensure the emission limits for different vehicle categories. But still, it is a doubt. This is not going to serve the requirement of low or no carbon emission. This is one of the Kajin books. He has made a study and he said this is not going to meet the carbon emissions requirements which are specified or stipulated by various regular agencies. Now, I will just share what are this slide, what are the different fuel impact analysis. This has been a comparison of alternative transport technologies and specifically within India and with the different one is petrol, diesel, biodiesel, ethanol, CNG, all these how the hydrogen fueled vehicles, what are the different advantages are all each for each classification in respect of fuel availability, type of various alternatives, fuel, and all these things have been shared here. This these are the different relative comparisons for different types of vehicles when we go for which choice of the vehicle with what type of a fuel, what are the issues in different categories, in categorization as per the categorization with fuel availability, refueling infrastructure. Okay. In all these aspects, these have been highlighted, and Now, what is the pathway to zero emission vehicles? For zero emission vehicles, what is we have seen the different limitations of each type of fuel on the different categories. Then what is the next? What is the pathway for zero emission vehicles? The pathway speaks. This clearly says the path to electrification is only the specifically is fully electric or hydrogen fuel cells vehicles is the only solution, or we go for hybrid vehicles. If you see, this is going to reduce the carbon reduction potential in different ways. The different for zero emission vehicles, mid hybrid vehicles, fully hybrid vehicles and plug-in hybrid vehicles are the different categories which can be thought of for carbon reduction. And if I see, hydrogen fuel cells are going to have the maximum advantage from 50 to 100%. Depending upon the carbon reduction, the choice of the, what is the requirement of electrification has been shown, has been directed as per the carbon emission requirements and the norms. Again, if you see emissions from various fuel sources, if we find the different fuel thing, it is always advantageous to this fuel cell vehicles. The emissions are the least. Fuel cell with hydrogen emission, they are the least. Now, for all these things, what are the value chains? Biggest is the raw material. Today, the biggest raw material is the thread. The raw material among the raw material, the biggest raw material is the specifically which is facing the issue is the lithium ion. Lithium ion is a rare earth material, and this is one of the most demanding material, which will over the period of time will get plagued, and the price fluctuations can affect the impact the battery manufacturers. So this is one of the bottleneck over the period with the things which everybody has to think of it. We should have traditional component suppliers. Now, whatever is the traditional component suppliers, they should be tying up with all the EV industries or EV producing industries or hybrid and anything to produce EV parts so that the issues of spare supply will be reduced. Then battery manufacturers and suppliers should be there. There should be in the biggest EV industry, battery manufacturers and suppliers, they have a major role. And besides that, indigenously or for self-reliance, we have to do, there needs a lot of R&D has to be done for improving the battery of for the electrical vehicles. It is one of the major component for an electrical vehicle, and it is the highly costly. It is the costliest in the electrical vehicle structures, besides other things. Similarly, utilities. For the utilities, the biggest problem things is the charging stations. And for this, we have to think wherever the thing, because the for any EVs, the biggest is the additional demand for electricity. This additional demand of has to be met either through generated through using proper grid management or generating alternative renewable sources such as solar, wind, biomass, geothermal and hydro energy. Utilizing these, we have to think of an alternative sources of energy. And the biggest today, wind energy is one of the biggest thing which will definitely support the load profile of various electrical power requirement, because most of the battery chargings are done in the night, and for doing in the night time these wind energy will be the ideal for battery generating power supply, and it is also reduce the emission factor of the total electricity. This is how the ecosystem, if I go, if you see for various grids and all, the best ecosystem from the wind energy is found to be best. It is having balance and it is not going to affect any of the environmental economics at all. What are the biggest risks and challenges? What are the solutions have been enumerated? They have been put it based on some study, and it has been created as from scale 1 to 5. So from the scale to 1 to 5, if you see, the one is the biggest risks are the batteries, the risk. Batteries linked to the thing. And various all the factors that are contributing have been put into a tabulated form, and they've seen the scale 1 to 5, those labeled with high, they are posing the highest risk. So adequate care has to be taken to mitigate these risks. What are the question is, India has taken a lot of policies and for promoting electric vehicles. So biggest the various government agencies which take up EV mobility in India, their role and comparison, I will just share with you, so that for any development, whether it is R&D or thing, these agencies, nodal agencies can be always approached for solutions within the country. And even anybody can approach this and discuss with these agencies for a stronger EV base in our country. One is National Council for Electrical Mobility, NCM. It is the apex body in deciding matters relating to EV mobility. This is the body which totally entire EV mobility is regulated by this board. National Board for Electricity Mobility. This consists of members from ministries and from industry and academia. So this is another body where academia means educational institutes, industry, and the ministries they are the members, and all the issues relating to this can also be discussed on technical and the various stakeholders on the various implementation methodology, because it's a cross mix of people from industry as well as academia and as well as the ministry. Another major board is the National Automotive Board. This National Automotive Board is governed by these two. So it is the thing, the board, this is the responsible for facilitating between the government and the industry and promoting R&D activities in the sector. This is what is the general information I thought I should share with you people today. Any questions? You're free to ask. to the battery will get affected.
Hello, sir. Repeat చేయండి మరి.
External environment, yes, it will affect the battery because the battery starting and battery functioning will depend upon the environmental temperature. These are all these temperatures are defined by the battery manufacturers between maximum and the minimum limits. Any temperature which exceeds these limits will definitely affect the temperature of the internal environment because of the heat transfer between the external environment and the battery internal resources. Definitely it will affect the things. See, one is aerodynamics is there are for EVs, the biggest aerodynamics is fluid flow dynamics and the drag effect, the effect of drag, friction effect, rolling resistance studies are to be done in for the aerodynamic dynamics of the EVs. Efficiency of recycled battery is not that good because recycled battery, its battery life, it depends upon the SOD, state of discharge, and the life cycle. So the more the if their battery is liquefied after a perceivable long time, it is not that much of useful compared to the NU battery. డేటా షేర్ చేస్తారా చేస్తారా
Participants, the validatory section will start at 12 noon. After validatory section, the link will be shared for quiz test. You can respond through that link. Please join by 12 noon. The 12 noon exactly the validity section will commence. And during the validity section, group photo section will be there. After validatory address, groups photo section will be there. Then link will be shared for the quiz test. Welcome to the participants.
The time has come to draw the curtain to our program as we come to the close of it. Very good afternoon and a warm welcome to everyone to this rather short program of Series 2 of 1 week online factory development program on trends and challenges in the development of electric and hybrid electric vehicles. During the last few days, we have had several deep insights into various aspects of electric and hybrid electric vehicles development, challenges, and also the probable remedies for the same. We had eminent personalities from different fields who have enlightened us both from national and international levels. I hope you have learned much from these sessions. This afternoon, I would like to acknowledge the dignitaries present with us. Our convener for the day, for the event, Dr. Sridhar sir. Our speaker for today, Mr. Deepak, design engineer from Volvo Trucks USA. And our keynote speaker, Dr. Lalit Kumar Sahu sir from NIT Raipur. First of all, I would like to invite our convener for the event, Dr. K. Sridhar sir, to give a brief report on our FDP. Over to you, sir.
Good afternoon, all the participants for this validity section. Welcome to Dr. Lalit Sahu sir from NIT Raipur. We selected this theme, electric vehicles and hybrid electric vehicles, because most of the automobile companies are going to switch to electric, a cleaner and sustainable alternative. An electric revolution is coming to the automobile sector across the globe, but industry is facing a shortage of talented and skilled engineers needed to be transitioned to electric drives as a primary source of motive power to conduct this program. And across the globe, EV charging infrastructure is still not stabilized. Accordingly, the program focused on providing theoretical as well as practical aspects of electric vehicles infrastructure development, and thereby enabling the researchers and academicians and industries to promote industry and institute collaborations by working on current research problems. To make the participants to familiarize the concepts, the Department of Mechanical Engineering, Learning Institute of Engineering and Technology has organized this section in Series 1 between 26th October to 30th October 2022. We got very good response from the research scholars, industrial executives, and teaching faculty during the Series 1 that make us to conduct this Series 2 program, where expected that the FDP will provide an excellent opportunity for faculty members and research scholars and industrialists to have an interaction with nationally and internationally renowned experts in the area of electric vehicles. And during the Series 2, we have received more than 1,000 registrations across the globe. Participants are from Algeria, Australia, Bangladesh, Ethiopia, Finland, Germany, Malaysia, Nigeria, Pakistan, Philippines, Saudi Arabia, Singapore, Spain, Sri Lanka, Sweden, Taiwan, and USA. And from India, registrations are from all the states, including Northeast states and Union territories. And the first day on 14th November, Mr. Rohit, project manager e-mobility, TE Connectivity German, he enlightened us related to the development of EV across the globe. He has given good comparison between the design aspects of EVs by the different manufacturing companies. On the same day, Dr. Kishnakumar Gupta sir from Thapar Institute of Engineering and Technology, Patiala, enlightened the participants on advances in power technologies for electric vehicles. On 15th November, Dr. Chinmaya from Indian Institute of Technology, Varanasi, has addressed the participants related to categorization and comprehensive insight of electric vehicle technology. And on Wednesday, 16th November, Dr. Vidyasagar from University of Huddersfield, England, addressed related to the issues related to EV battery and SOH estimation. And on Thursday, 17th November, Dr. Gimsa Grusso, professor in Milano Technical Institute, Italy, discussed on the concepts of impact of EV charging and electrical infrastructure from forecast to demand response. Today, that is 18th November, Mr. Deepak, design engineer and project manager from Volvo Electric Truck, North Carolina, United States of America, discussed about challenges and issues related to EVs. And particularly, I am grateful to the speakers from England, Italy, and USA. Irrespective of the time zone, they considered our difficulty and they adjusted their slots to address the participants as per our convenience of the Indian time. And today, Deepak sir also, even though it is midnight, still he spared the time to address our participants. I am thankful to all the speakers from India and abroad. Hope the participants have got relevant information from the speakers, and the speakers also answered well their queries. The organizing committee from the host institute also, they got good information from the speakers. We also put many queries to the speakers. Generously, they answered the questions from the participants and from the organizing committee with more patience. Thank you very much for all the speakers and all the participants. Now, we have Dr. Lalit Kumar Sahu sir with us from IIT Raipur. Sir is going to deliver valedictory address. Welcome, sir. Welcome, Dr. Lalit Kumar sir, to the valedictory section. Please
Thank you,
start
sir.
your advice, sir.
Thank you, sir. Thank you so much. It is my privilege to be a part of the valedictory session of series 2 of this particular FDP focused on electric vehicle and its associated domain. A warm good afternoon to all the dignitaries and participants. First of all, I would like to congratulate the Department of Mechanical Engineering, Lend Institute of Technology for successfully conducting the Series 1 and Series 2. This is the Series 2 on electric vehicle, and I really like to congratulate them for such a big success of the event. As Professor Sridhar Algi was mentioning, that it is one of the successful FDP at a very international level, where the participant from all part of the globe have attended the event, and as he has mentioned the different country name. So definitely it is a big event globally. So I congratulate the coordinator, the department, and the institute for this event. As far as the electric vehicle and associated domain is concerned, in last 1 week, all the participants have gone through the different, technological background and emerging trends related to the electric vehicle. To be more specifically on the research trends, upcoming trends related to the drivetrain technology, battery management, power management, architecture, its operation, and another segment of this is the charging stations. So in the several part of the world, these technologies are getting really matured. The consumer demand are getting very high, and the electric vehicle manufacturers are really doing well. And the developing country like India and several other countries where we look at as an India, if I talk about, it is a land of opportunity. We have a huge opportunity, and electric vehicle has started penetrating into the Indian market. Several auto manufacturers have launched their electric vehicles, and several auto manufacturers are, on queue to launch their electric vehicles. So if you see in terms of the opportunity, so this electric vehicle and the associated domain brings a huge opportunity for both, for the academician to look into the research point and further development, and for the industry to bring or to incorporate those emerging technologies and development more and more into their commercialized product. Still in India, the commercialization is very uh, slow, and only a limited people have access to the electric vehicle as of now, especially in terms of the four-wheeler and higher side. In two-wheeler, we are really doing well, and in upcoming time, as far as my understanding is concerned, we can see more electric vehicle on the road in terms of the higher taxis. These guys are going to take it more aggressively in comparison to the general people, as the auto manufacturers are pushing more and better and newer model to the electric vehicle. So slowly definitely will increase to this adoption and consumption of the electric vehicle in coming time. And as if you see the government of India's vision 2030, then certainly the future is good in terms of the electric vehicle. Some of the challenges and research opportunity that I see in domain of electric vehicle is, one thing is on definitely on charging station side. Everybody is looking to have a charging experience similar to the way they have the refueling experience with their IC engine vehicle. So whatever amount of time that they take to refuel their IC engine vehicle, the expectation of the consumer is somewhere in that. If not exactly in that, then little bit higher to that, but not much higher in ours, right? So one of the good opportunity. So one of the good opportunity in the charging station that I see is this, the fast charging station and the extreme fast charging station. Already the researchers are putting their dedicated effort day in day out to make it more faster and faster approach to charge the onboard batteries at a prototype level. They many of the research team across the globe have received significant success in the line, but still it is yet to be commercialized. And if I see some of the research trends towards the electric vehicle side, then the swappable battery is one of the technology that I'm looking that will change the game, because to minimize the charging time, as I said, the battery is the bottleneck of the technology, and battery charging time is another major issue with it. Yeah. So to have a sustainable swappable technology where you can go to a particular service station, and in fewer possible time, if you can swap the onboard battery, this is one of the best and easiest and safest way one can have. And the third opportunity that I see towards this electric vehicle is the battery management. How you can extend the life of the battery, how you can, exploit the maximum possible power available on board on any of the electrical vehicles. So these are 3 to 4 emerging trends and research challenges that I particularly see and understand that the upcoming research will revolve around. So with this, I will summarize my valedictory note. I won't like to speak much, as many expert, many eminent personality around the globe has already spoken a lot in a specific domain of the electric vehicle. So I won't be going to repeat all those things. So thank you all for giving me this opportunity to be a part of the valedictorization of this electric vehicle FDP Series 2. My congratulations to all the participants and to the organizing committee and the institute. Thank you. Thank you so much.
Thank you very much, Dr. Lalit Sahu, sir. Participants, Lalit Sahu, sir, helped a lot for the initiation of this FDP Series 1 and Series 2. Actually, we selected this concept of electric vehicles because it is a current topic and many issues are there from the user side. Still, research is going on, development activities are going on with the manufacturing companies. With that concern, we thought that it is better to select this topic. Then I approached Dr. Ali Sahu, sir. Sir generously has given more information to me to initiate this FDP. Thank you very much, Dr. Lalit Sahu, sir, for your guidance and help to initiate this FDP. Later, I consulted many other friends to get the information from the international speakers. And this time, 3 international speakers have delivered their lectures. And participants also, they put the good queries. And we shared more information from the participants also. Thank you very much, Dr. Lalit Kumar, sir. And thank you very much, participants.
Thank you, sir. It's now time to hear the feedback from the participants. I would like to invite the participants to share their views on the FDP and give us the feedback so that we might have to do in the next coming FDPs. So if you would like to speak up, please use the hand raise option so that we can unmute you. And then we'll enable you to speak. Yes, we would like to hear from the participants. Anyone? Please use the hand raise option so that we can unmute you. So when I say feedback, it doesn't mean only the good ones. You can also share anything negative so that we can try to improve the next one. So,
we are expecting feelings from the participants related to the sections and the suggestions for further improvement. And many participants they voted through chat box. If we hear your voice, we'll be happy.
so I don't think we have any feedback from the participants. I hope everything went well and you have enjoyed all the sessions. So it's time to, yes, we have some participants who are raising their hands. One, Mr. S. Kiran. So you can please unmute yourself and speak. R.S. Kiran, sir. We also have Mr. Vinayak Kulkarni. So you can please unmute yourself and speak.
Hello, very good afternoon to all.
Yes, good afternoon, sir. Yes, sir, we can hear you.
Okay. Yeah. My name is R.S. Kiran. I'm from SITAM Vishakhapatnam. Actually, I would like to congratulate the organizers, first of all, for arranging a wonderful presentations sessions from all over the globe. And it was really my wonderful opportunity to have been the participant for the session series 2 of the electric vehicles domain. And I really thank the management of the institute also for giving me an opportunity. And a lot of things have been discussed, and whatever challenges are there before the EV domain has been very well dealt with, so that even the future researchers as well as the budding engineers can have an idea about what could be done in the field of EV, and the students can definitely contact the participants also. whoever has attended this international series, because everybody might agree with me that we have learned new knowledge, and we have gone through different areas of research that could be explored out. And really, it was really wonderful session, because all the sessions were very much simplified, specified, and standardized, and could be very well diversified into the research domains as well. So thank you all for giving me an opportunity, and I congratulate all the participants also, and thank you all the organizers, and thank you, sir. Thank you. Over to you.
Thank you, sir. Thank you very much for your feedback. Sure. I request now Dr. Anand Kumar Singh, sir, to please speak.
I am audible, sir.
Yes, sir, you're on.
Congratulations to all the organizers and the eminent people. They are all are excellent. Uh, so I like every session. So thank you very much for organizing this FDP, sir. Thank you, sir.
Thank you, sir. Thank you. Anybody else would like to speak? Okay. Yes, we have Mr. Vinod Verma. Sir, please unmute yourself and speak. Vinod, sir.
Yeah, very good afternoon to all of you. I think I'm audible.
Yes, sir, you're audible.
Yeah, so first of all, congratulations to all the committee members and the organizing team, as well as the resource persons who have delivered this topic very well. And I would like to share my experience, because uh, since last 2 years, this course was introduced in our university. I am from Bikaner Technical University, and presently as a assistant professor in Government Engineering College, Ajmer. So it was a challenge for me also to teach this subject, because the resources are very, very rare. As well as 2, 3 things I would like to add over here, that because in North India, students have very much problem with English language also. So this course is not available in our local languages or Hindi, basically, because if we will talk about the lower cadre, like whenever we need mechanics and all mechanics and lower people's diploma holders also for working in the field, they have a tough time in electric vehicles, because there is no resources available. So my request to all the dignitaries over here also, that they should look into it, that submission. Am I audible?
Yes, sir, you're audible.
Yeah. So one of the submission is like this, that please try to arrange if this domain is available for other languages also. And regarding this session, it will be very nice if we will able to get the recordings also, because sometimes due to some commitments, we are not able to hear some of the lectures. So it is very important that we can go through all the lectures precisely one by one, again in detail, whenever we will get more time. So this is all from my side. Once again, congratulations to all of you.
Thank you.
Thank you so much.
Thank you, sir. Thank you very much.
Thank you, Dr. Vinod Verma, sir. One thing is, it is international FDP. Speakers are from across the globe, participants also across the globe. That's why we selected the media as English. And I understand your problem. I know it, what is the difficulty in North India. And ASUT also encouraging to publish the books in the Hindi language. If possible, we will conduct one section separately for the tradesmen and other technicians separately in the local language. As per your advice, we will try our level best, and we will share all the PPTs and videos to all the participants. Series 1 already we shared. Series 2 also will share all the PPTs and YouTube links also for the convenience of the participants. Sometimes they may miss part of the lecture also. It will be useful for them. Thank you very much for your advice, sir.
Thank you, sir. Thank you very much. We have Tanuj Rawat. Sir, can you unmute yourself and speak?
Audible now?
Yes, sir, you're audible.
So good afternoon, everyone. And it was really a very good and informative FDP. And as others have already said that this is the trend which is going on right now about electric vehicles, and in universities also, and even as a research scholars, masters and PhD candidates also, they are trying to move into this area. So overall, I found that this FDP was very useful to give a starting kick for them or anyone if someone wants to work in this area. So I would like to congratulate everyone who were involved in organizing this FDP. Thank you.
Thank you, sir. Thank you very much. I think that's all from the participants' end. We would like to proceed with the program. Thank you very much for your feedback. I'm sure we will definitely take them into consideration and improve in the future as well. Before we come to the closing vote of thanks, I would request all the participants to turn on their videos so that we can have a snapshot of the gathering. If you can turn on your videos. It will take maybe a couple of minutes. Until then, please be patient.
All the participants, please on the videos.
One more minute, please. Okay, thank you, participants, for turning on your videos for the picture snapshot. To formally end this valedictory session, I would like to propose the vote of thanks. The faculty, friends, delegates, distinguished guests, committee members, greetings from the Department of Mechanical Engineering, the Indian Institute of Engineering and Technology. On behalf of the organizing committee, I would like to express my appreciation and thanks to all the participants of the Series 2 of 1 week FDP on trends and challenges in the development of electric and hybrid electric vehicles held between 14th to 18th November 2022. As a coordinator for the FDP, it's been a pleasure to host all the participants of this FDP via the online WebEx platform. Participants were very enthusiastic, and I'm thankful to all the participants for joining from different parts of the country and also from abroad. We have been very fortunate to have some of the eminent persons from the academia working in the area of electric and hybrid electric vehicles. I'm sure that the participants must have benefited much by attending this FDP. I'm very much thankful for the management for funding this FDP, because without their generous financial support, it would not be possible for us to organize this event. I sincere thanks to the Honorable Chairman, Dr. Sri Madhusudan Rao Garu, Honorable Vice Chairman, Sir, Sri Srinivas Rao Garu, Honorable Secretary, Sir K. Sri Ramakrishna Garu, for their constant encouragement throughout this event. I'm very much thankful for our principal, Dr. V.V. Ramareddy Garu, for the continuous support and advice, which have greatly helped toward the successful organizing of the FDP. I sincerely thank our chief guest and keynote speaker for the first day, Mr. T. Rohit from Germany, for kindly accepting our invitation and gracing this inaugural function. A very special thanks to all the speakers who have spared their valuable time and graced this FDP. I also thank Mr. Deepak, design engineer for Volvo Trucks, who have been a session speaker for today. A special thanks to Dr. Lalit Kumar sir from NIT Raipur, who have given us the keynote address for this valuable section. I'm also thankful for the organizing team that led at Lend Institute of Engineering and Technology. I would like to acknowledge the unwavering support received from the faculty and the staff members. My thanks also goes to the people who have given their precious time to make this event memorable. The convener for the event, Dr. Sridhar sir, the organizing team members, Mr. Ramladar, Mr. Kamesh, and all the others. I finally would like to thank all the participants who have given the valuable feedback. We will definitely take your feedback and improve for the next one too. So the response for this FDP is tremendous, and we are sure that we will be organizing FDPs on similar topics and also on the other topics as well. This time, even in a better way, taking the consultations and feedback from the faculty and from the keynote speakers. I once again thank everyone who have made a very significant contribution to this FDP and made it a successful one. Thank you everyone. Before we close, I would like to inform all the participants that the feedback online test link will be posted in the WebEx chat box immediately, and it will be open till 1 p.m. So I request all the participants to please 1:30. We would like to extend because it's already 12:35. We'll keep it open for 1 hour from now. I request the participant to please click on the link. It will be shared right after the end of the program. So the participants who have fulfilled the criteria of the attendance and also the test marks will be eligible to receive the certificates along with the recorded lectures. The certificates can be expected within 7 to 10 days. So kindly please cooperate with us. Around 7 to 10 days it will take for all the certificates to be sent to you by filtering and all the other things that we are going to. So thank you everyone for your participation. Now as the national anthem is being played, shall we all rise up and then we'll sing the national anthem and we will end our session.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Jai Hind. With this, we have come to the end of the FDP. I hope you have learned much and something new from these past few days. That's all from my side. Have a great day, and until next time, Daniel signing off. Thank you very much. The feedback link and the test link will be posted in the chat box. The feedback on my assessment link has been posted in the chat box. I request the participants to please fill the feedback and complete the test. The link will be open for 1 hour